The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom-built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.